What's going on, friends? If you are familiar with programming languages like JavaScript and Java, you might have encountered the switch case keyword before. It looks similar to this. We declare a variable called day and use the switch keyword to check different cases. For example, if the day is Sunday, this corresponding block of code is executed. Then we break out of the switch. If no match is found, the default block is executed. Fortunately, the switch case concept has been recently introduced in Python 3.10 and it is more powerful and flexible than you might think. Python refers to it as mach case. Join me in this lesson as we explore the capabilities of this awesome feature. Without further delay, let's get started. Alright friends, the match statement evaluates the value after the match keyword and checks it against a pattern. A pattern is the code next to the case keyword. If the status is 400, then this block of code is executed. If it is 401, this block of code is executed. There is no need for the break keyword. The default block is represented by an underscore. This is similar to the else keyword when using if statements. If no match is found, then this block of code is executed. Let's declare a variable called day, which is a string data type. We bring in the match keyword, followed by the variable we want to match. Then comes the case keyword. If the day is Monday, this inner block of code will be executed. You can write as many lines as needed in the inner block. Another case we would like to try is Sunday. If it is Sunday, this inner block of code will be executed. Case Friday. This inner block of code will be executed. We want to provide the default block if there is no match. Print no match found. So now let's try to execute the program. The expected result is Monday because the variable matches Monday. Let's execute the program and see the output. The output is Monday. If you try to use Friday, the output should be Friday. Great. Let's update the variable value to OP. Of course, there won't be any match for this. This means this part of the code will be executed. This is similar to the else block when dealing with if statements. Let's run the program and see the output. Great, no match found. There is a string data type. We can use any other data type such as number and boolean. The if-else version looks like this. The match case version is cleaner. Sometimes we need to handle multiple cases in a single block. The pipe symbol can be used to match multiple values. For instance, we can decide to combine 401 and 403 in a single block. We just need to make use of the pipe symbol 403. Then we remove this other part, authentication error. This means both 401 and 403 will be captured by this case. Let's try to use 401. Run the program and see the output. Great, the output is authentication error. If we also change it to 403, the output will be authentication error. Let's run the program again. Great. We can use the pipe symbol to combine as many values as needed. In addition to matching variables like strings, numbers, and booleans, the match case statement also enables you to match specific data structures such as lists, tuples, and dictionaries. I have declared a variable here which is a list data type. Match the variable we want to match items. Case A, B. Point two items are present. Point F string A is A and B is B. Another case to consider: A. Point one item is present. Point A is. Now let's move on to define the default case. Point no match found. The first case is designed to match a collection, whether it is a list or a tuple, containing two items. The variables A and B serve as references to these items. You have the flexibility to use any other variable names of your choice. A refers to the first item, while B refers to the second item. If there is a match, this inner block of code is executed. We are making use of the variable A and B in this line of code. The second case is designed to match a list or tuple containing just one item. A serves as a reference to the item and it is used in this line. If no match exists, then the default block is executed, which is this line of code. When we execute this program, this block of code is executed because it matches a list or a tuple containing two items. Let's run the program to see the output. Great, the output is 2 items are present, A is 1 and B is 2. Now let's update items to contain just one item, 1. The expected output is this block of code because only one item is present in the collection. Now let's run the program again. Great, one item is present, A is 1. If there is no match, this block of code is executed. Let's execute the program and see the result. No match found. To match an empty list or tuple, we can provide another case. Case empty list or tuple print no item in the collection. So now let's want to run the program. The expected output is no item in the collection because this is going to match an empty list or tuple. Let's run the program to see the results. No item in the collection. That means this part of the code is executed. We can also match for specific values within a collection. Let's modify one of the variables to be a string, array. We also need to update the print statement because variable A is no longer available. This case will match a collection where the first item is array, which is a string data type, and the second item can be any value. The value of the second item is captured in the variable B. Let's modify the contents of the items to be array. The expected output is 2 items are present, B is 2. Let's run the program to see the output. Great, 2 items are present, B is 2. Any other string which is not array is not going to match. Let's run the program. The expected output is no match found. Great, no match found. So far, we've been matching lists and tuples. In this one, we are going to use a dictionary. Match information case, the first case, age, name, print, f string, and name is name. Let's also provide a default case, print no match found. The first case involves matching a dictionary where name and age are present as keys. The values are captured as age and name. You can use any variable names of your choice. There will still be a match if extra keys are present in the dictionary. For now, if we try to execute the program, the output will be not found because name is present in the dictionary but age is not present. Let's run the program to see the output. Great, no match found. So now let's try to update the dictionary to include age as well. Age 10. This block of code will be executed because there is a match for this dictionary. Age can be found in the dictionary and name can also be found in the dictionary. The order of items in a dictionary does not matter. So let's run the program again and see the output. Great, age is 10 and name is Ray. We can also match for specific values in a dictionary. Let's try that out. Age is 9, name is Ray. This is going to match a dictionary where the value of the age is 9 and the value of the name is Ray. For now, if we try to execute this program, the output will be not found because age is 9 but name starts with uppercase. Meanwhile, it is lowercase here. Let's run the program and see the output. Great, not found. We need to update the value of name for it to be able to match. Let's run the program again. Great, age is 9 and name is Ray. The rest of the items in a dictionary can be captured using double asterisks. Let's try that out. Age is 9 and the rest of the items can be captured in a new variable. Let's call it rest. This is going to match a dictionary where age is present as a key. All other keys and values are captured in rest. We can then access the items by using the keys print, rest, name, print, rest. This is how we can access items in a dictionary. So now let's run the program. Ray and 10. There's no need for this bracket. Let's execute the program again. Ray and 10. Specifying a key that does not exist can lead to key error. Let's say contact. This is going to raise a key error because contact key cannot be found in the rest. Let's run the program and see the output. Key error. Contact. Conditional matching allows us to perform additional checks before executing a block of code. Let's declare a variable called status. Status equals 5. Match status case x. If x greater than 0, print positive number case x. If x less than 0, print negative number. Case, the default case, print 0. In the first case, we want to match for x and verify if a condition is met before executing this inner block of code. X is just referring to the matched value. In the second case, if x is less than 0, then this block of code is executed. If no match is found, then the default case, which is this line of code, is executed. Let's run the program now and see the output. Positive number. Let's update the status to be a negative number, -1. Let's run the program again and see the output. Negative number, -1. So now, if we use 0, these two cases are not going to match. So let's run the program again. The expected output is 0. Great. You need to be extra careful when using conditional statement. For instance, if I change the status to be a string, let's run the program and see the output. Type error, greater than not supported between instances of string and integer. This error is because x is captured as a string and we are now trying to perform math between a string and a number. This is not going to work. The fix for this will be shown when dealing with type matching. Let's try out one more example. Item, which is a list data type, 1, 2. Match, item, case, x, y. If x plus y greater than 4, print sum is greater than 4. Another case, if x plus y less than 4, print sum is below 4. The first case is going to match a list or a tuple containing 2 items. But before we move on to execute this inner block of code, we want to do some further checks. If x plus y is greater than 4, then this block of code should be executed. Remember, x is pointing to the first item in the list, while b is pointing to the second item. If this case is not matched, then we want to try another case, which is this case. If x plus y is less than 4, then this inner block of code should be executed. Sum is below 4. Let's run the program and see the output. 2 plus 1 is 3. 3 is below 4. Let's run the program. Sum is below 4. Let's update the items in the list. 5. 6 is greater than 4. So the output will be sum is greater than 4. Let's run the program. Sum is greater than 4. Sub-pattern match involves matching a pattern inside a pattern. Let's try out an example to understand this. Route equals go east. Match route. Case go east or west or south or north. Print go to the direction. The default case, print no match. What we have here is a pattern, a list or a tuple. The first item is expected to be go and the second item is a pattern. This is going to match any of these items as specified by the pipe symbol. So now let's run the program to see the output. Go to the direction. Let's update the list. West. Execute the program again. Great. Go to the direction. The question here is, how can we get the specific value matched? The as keyword in Python can be used for this purpose. We just need to say this second item as direction or any other variable we want to use. Let's update the print statement to capture the direction. So now let's run the program. The output should be go to the west. Great. So I'm going to update this to be east. Execute the program again. Go to the east. The match case statement supports matching the type of a specified value. Here is an example. X equals 5. Match x. Case string x. Print x is a string. Case int integer. Print x is an integer. Alright, this case ensures that when x is matched, it is a string data type, and if it is an integer, this part of the code is executed. Let's execute the program to see the output. X is an integer. This block of code is executed because x is an integer. Let's update x to be a string data type h. Let's run the program again and see the output. Great, x is a string. Let's use one of the previous examples to show a practical usage of this. Let's change the second item in the list to be a string. So now let's run the program and see what happens. Python throws a type error. Unsupported operand types for plus int and string. In this line of code, we are trying to perform an addition between an integer and a string. That is why Python raised a type error. To ensure that the matched items are of a specific data type, we can use type matching. The first item should be an integer, and the second item should also be an integer. If they are not integers, there won't be a match, int. Let's provide a default case, print, no match. So now let's run the program and see the output. Great, no match. This means the two items present are not integers. This is particularly useful in order to avoid any kind of error in the program. Let's change the second item to be 9. So now the program should run fine. 9 plus 1, 10. 10 is greater than 4. We haven't mentioned how we can capture a set data type. The type matching can be used for this purpose. We just need to define another case, set of x, print. X is a set type of x. Let's update this variable to be a set data type. Now let's run the program again and see the output. X is a set. Alright friends, let's recap what we have learned in the lesson. The first match is a constant match. This is going to match a string, number, or a boolean data type. The second case is going to match a list or a tuple containing two items. The first item must be string A and the second item must be string B. For this one, it matches a sequence containing exactly two items. The two items can then be referenced as variable A and B in the block. This is going to match a list or a tuple containing two items. But the first item must be string A. The second item can be any other value. This is going to match a list or a tuple containing at least one item. The first item is referenced as A, while the rest are referenced as B. The pipe operator signifies OR. It means any of these values is going to match. We also have a conditional matching, which is used to do any further check. This is going to match a dictionary where name and age are present as keys in the dictionary. An underscore is referred to as a default case. This case is similar to the else keyword when using if statements. This matches a list or a tuple containing two items, but the values of the two items cannot be used in the block. That is why they are represented as underscore. To use the values in the inner block, we can make use of any other variable names. This will match a list or a tuple containing two items, but the first item must be a string and the second item must be an integer. If you missed the previous lessons, make sure to catch up on them. Thanks for watching and see you in the next video.